All right, in this video, we're going to be talking about balancing organic compounds. Now, first, just to make sure we understand what organic compounds are going to be compounds that typically have carbon to a number and hydrogen to a number. Okay? If you've been in my class before, we've talked about things like butane, we've talked about propane. Okay? We've talked about these things. You've heard of these before. Maybe you've even heard of octane, which is found in the gasoline of your car. A butane lighter, okay, like you light a gas grill. Propane is the gas you use for a gas grill. The igniter is usually butane. Octane is found in the gasoline of your car. Okay, and there's lots of different versions of these. They don't all end in ane. There are things called butene, propine. There's all kinds. There's a whole branch of chemistry that is nothing but organic compounds. But when we're going to talk about balancing them, these are some of the ones that look really easy, but sometimes they can be really hard. So let's do an easy one first. I'm going to give you some hints to make your life a little easier. All right? This is typically what it looks like when you balance an organic compound. So basically what this is you're going to learn this in a video coming up, but it's what is called a combustion reaction. And I use that word right now because you know what this word means. Combustion means to burn. Anything that burns is combustible. It burns, combustion, okay? Now, for a fire, all fires need oxygen. If you cut off the oxygen, it goes out. That's why you use a fire extinguisher. But whenever something burns, so in this case we're talking about organic compounds, oxygen, it's going to make carbon dioxide and water. Now, we are an engine. We're just not a really good engine. And the idea is that whenever we take food, carbohydrates, fats, proteins, lipids, all that kind of stuff, we breathe in oxygen and we breathe out what? Carbon dioxide. And we produce water. Okay, and you see that in sweat and saliva and all those kinds of things. It's the byproduct. Now notice there's carbons on both sides, there's hydrogens on both sides, and oxygens on both sides. This is why it can be a little harder to balance. So what we're going to do is we're going to do this one really slowly like this. Carbons, hydrogens, oxygens. Now, a helpful hint. Oxygens, when they're all over a reaction like this, it's best if you do them last. Best if you do them last because because any number I put here affects my oxygens. Any number I put here affects my oxygens. So let's do everybody else. Got one carbon. That's balanced so far. 4 hydrogens and 2 hydrogens. That's not balanced. We're going to have to fix that. Oxygens, grand total of 2. Grand total here, 2 there, 1 there, it's 3. Now I already told you the hint. I've done it for years and years. Always do oxygens last. So let's fix our hydrogens. If there's 4 there, that means I need a 2 there. By doing that, I now have 4. Now who did I mess up? Well, as soon as I put that 2 there, that helps my hydrogen, but it messes up my oxygens. So who did I mess up? Well, 2 oxygens and 2 more is 4. Now look what just happened. If I have 2 on this side and 4 on this side, I can easily fix that with a big 2 there, and it is balanced in all the places. So my coefficients are 1, 2, 1, 2. I don't ever have to write the ones. As a matter of fact, most times you'll never see the 1, but it's understood to be a 1. Balancing an organic compound. Now, that's not too hard. Seems pretty easy. But they do get harder. So let me show you what I'm talking about. I have another whiteboard here that has a couple of examples on it. So let's try to balance this one. Okay? And this time, I'm going to do it. I'm going to start with the bottom one, and then I'm going to work up. This is acetylene. If you know someone who uses an acetylene torch, they cut things with it. It is a gas that's very, very hot. Use oxygen, and it's used to cut things. Okay? 2 carbons, 2 carbons. So I have carbons, hydrogens, and oxygens again. Looks just like the last one. 2 carbons, 1 carbon. 2 hydrogens, 2 hydrogens. That one's fixed so far. 2 oxygens and 3 oxygens. Okay? So I got to be careful. Remember, oxygens are last. So fix my carbons first. I'm going to put a 2 there. That fixes my carbons. But who did I mess up? Well, it changed my oxygen numbers. That's 4. That's 5 right now. And then I've got oxygens. Okay, hydrogens are already fixed. So my carbons are fixed and my hydrogens are fixed, but I can't make that work. Oh man, I'm glad this happened. Okay, so notice I have an even and an odd. And I can't make them work. Now I'm telling you that this is a correct formula. Acetylene with oxygen makes carbon dioxide and water. But what happens? I can't make it work. Here's what happens, and this happens sometimes, and you cannot tell by the way it starts. That looks like a really simple formula compared to that one. That one looks a lot bigger. Here's what happens. Anytime you have an even and an odd, you've got to make your odd turn out even or this one won't work. So let me just quick math real quick. Here's an even number and an odd number. If you take an even number and you multiply by 2, it's still even. If you take an odd number and multiply by 2, it's now even. So what's going to happen is if you work a problem, I've done everything and it's still not working, here's what you do. You put a big 2 in front and you just start over. And watch what happens. It'll solve itself. Okay? Now, with that big 2 there, I've got 4 carbons. That means, this is why you always want to do these in pencil. See how I erased? 4 carbons means I need a 4 right there. So that's good. Do I do oxygens next? Nope, I'm going to do hydrogens. Right there. 4 hydrogens. I've got 2 hydrogens, so that means I need a 2 there. Those are good. 4 carbons, 4 carbons, 4 hydrogens, 2 times 2 is 4. Got it. Now check out what's happened to my oxygens just right there. There's 8. Right there is 2 more. Grand total is 10. Look, it fixed itself. 2, 5, 4, 2. How did that happen? When I worked it the first time, I came out, everything was working. I had an even and an odd. Remember I had a 2 and a 5 here and it wasn't working? If that happens, put a big 2 out front. What's that going to do? It's going to make everything come out evens and it'll work. You can't tell if that's going to happen or not. Let's try another one real quick. I'm going to use the point method this time. 4 carbons means I need a 4 there. There's my point method. Hydrogens, 10 and 2. 5 times 2 is 10. So I've got my carbons, there's 4 and 4. 10 hydrogens. Let's check my math. I've got 8 here of oxygens and 5 oxygens. 8 and 5 is 13. Uh-oh, what do you think I do? Put a 2 out front and just start over. Take the numbers out. And see, I didn't even know it was going to happen until I worked it. Okay, it happens to me all the time. Now, how many carbons? 4 times 2 is 8. So I need 8 carbons. Hydrogens, 20. Means I need a 10 there. So when I do that, I have 16 oxygens and 10 oxygens. Be careful when you count that. That's 26. What times 2 is 26? 13. Now let me give you a really big hint. Look at your coefficients down here. 2, 5, 4, 2. If you were in math class and you had 2x equals 4, how do you make that easier? You reduce. Take out a 2 on both sides, right? So you reduce. So x equals 2 because it was a 2 on both sides. Now, every time you work a problem, this is just going to save you points. When you're done, look at all of your coefficients. Can I reduce it? 2, 5, 4, 2. It looks like a 2 comes out of everything, but does a 2 come out of that? Nope. Then this must be the answer. Can I reduce these? 2, 13, 8, 10. Nope. So that must be the right answer. So sometimes you're going to have big numbers. Look, it's starting to get 13s and 8s and 10s. That's fine. Let's look at one more real quick. Okay, and I'm going to put 3 on here. Okay, so if you need to pause the video, you can put 3. But I'm really going to work the one at the bottom, the third one. Now I want to show you the first 2. C5H10 plus O2 makes CO2 and water. But it looks like I wrote it again. See, sometimes when things burn, they burn completely. We're going to learn this. Greater, what do we call these reactions? They're combustion. It's burning completely, so I have all the oxygens possible. But sometimes things don't burn all the way. And we get carbon monoxide. And you know that carbon monoxide is poisonous. And so do you think the coefficients here, 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 and here are going to be the same for the second one? Here, 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 and here? No. But you have to really be careful and count. If you want to try that one, you can. Pause and do those 2. But I'm really going to work the one at the bottom. If you're interested in the other 2 as practice, feel free to do them. But I want to do the one at the bottom. So I'm going to do the point method again. 8 carbons means I need an 8 there. 18 hydrogens, 9 times 2 is 18. Now, I have 16 oxygens and 9. 16 there, 9 there, is 25. Oh man, that doesn't work. So what do? Well, I go out front, put a big 2, and I just work it again. Just work it again. Now how many carbons? 8 times 2 is 16. Do it in different colors so it's easier to see. 18 times 2 hydrogens, so that's an 18. Numbers are getting really big. 16 times 2 is 32 oxygens, and 18 oxygens is 50. That means that's a 25. Do those numbers reduce? No. So let me give you a really big hint. Ready? See how big these numbers are? Then I can expect to have big coefficients. Okay? So when I was working, the very first one I did, it has 4. So I'm not going to have very big numbers. But when I start having big numbers like 8s and 18s, then I can expect to have really big numbers here. Now I'm going to show you one more that's a challenge question. You don't see this all the time. And actually what I'm going to do is, if you miss this one, you can go back in the video and watch it. But I'm going to show you this one real quick. If I get ahead of you, pause the video and write it down. Now, just to help you a little bit, this is an alcohol. Now, there's lots and lots and lots of alcohols in the world. Anybody that's ever had a shot knows what isopropyl alcohol is. It's the one they put on a cotton ball, they rub it on you, and then they give you a shot. Okay? You know what that smells like. There's lots and lots of different kinds. There are hundreds of alcohols in the world, and it's an alcohol because it starts with a carbon and it ends in OH. Okay? I just know that because I've done it for a long time. But I want you to see what's happening here. This is a real challenge question. Big star. Challenge question. Look how many oxygens there are. That's why you want to do them last. Look, there's hydrogens everywhere too. So what I want to do in this question is I'm going to be really careful. We're going to work this one. This one's the last one, and this is one that you'll see every once in a while, so make sure you're ready. 2 carbons, got it. 1 carbon, got it. How many H's right there? 6. 5 and 1 more, 6 total. Okay, H's over there is 2. Okay, that looks like I can fix that easy. Total oxygens, 3. Total oxygens, 3. Doesn't look too hard, but watch what happens. Oxygens are last, right? 2 carbons, got it. Now that immediately affected, wow, look at that. Okay, so before I even count the oxygens, I can already see my H is 6 here, means that's a 3 there. So I've got 2 carbons, got it. 5, 6 hydrogens, 6, got it. I really messed up, so I've got 2 there, I've got 6 there, but look at the oxygens. 4 and 3, so there's 4 there and 3 there. That's 7. Now you got to be careful. Ready? Make that 7 a little bit better. Ready? I've got 7 oxygens, right? You think, oh, go out front and multiply by 2. Whoa, 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 be careful, be careful. If I'm correct, I've got 1 oxygen that's stuck there. Do I want to put a number right there? If I put a number there, it's going to change that number and that number. So let me do a little bit of detective work. I need to get 7. If I have 1 that's stuck in there, because I don't want to put a number right there, if I can get this to be a 6, isn't 1 plus 6 equal to that 7? So let me say that just one more time. I don't want to put a number here unless I have to. So I have an oxygen right there. There's 1. So if I can get this to be a 6, I get my 7. So if I have a 3 right there, if I'm correct, check my math real quick. Okay, I think I've got 7. 2 carbons, 2 carbons, got it. 5, 6 hydrogens, 6 hydrogens. Now, count carefully. 1 and 6 oxygens is 7 on that side. 4 and 3 is 7. I didn't have to put a 2 out front. Okay? So you have to be able to count. Take your time. The more hydrogens and oxygens you see, the more careful that you have to be as you go along the way. To be perfectly honest with you, it takes tons and tons of practice. You can do it. I know you can. All right? You'll get some practice ones coming up.